So let's look at the SQL. I think what I'm going to do for this filtering is I'm going to quickly run through all these three statements, letting you see that they are resulting the same result, and we will do some detailed analysis. So we get these 4 courses whose instructor name exists in instructor table with affiliation of Jedi. This 4, and this returns 4, and this returns 4. So that you can see all these 3 methods return the same value. So first of all, how are they similar? They are similar in the sense that they are associating 2 tables, 2 relations with 1 common column. And the second thing that are similar is in that they are executed as a nested loop, 2 layers of looping. They first start for the int clause. They first start with every row in the course table. For example, the instructor to the force, introduction to the force. It will find the instructor name in this row, Obi-Wan Kenobi, and then it goes to inside, selecting every row from instructor. And first of all, it will look at the where clause. If the affiliation equals to Jedi, then it's a match, right? It's a match, so it will select out the instructor name. If the instructor name happen to be Anakin Skywalker, then it will get discarded. But if the name is Obi-Wan Kenobi, then it's a match from the outside instructor name. Then this where clause stands for the main query. Then we will select this row from course. That's how the first row got selected. And similarly, it goes on and on, where you will try to match instructor's name inside. Now, select course. How about the second one? We do a join, and here it's the same. The course table joins instructor table by going through each row in course table one by one, and joins instructor table by going through instructor tables, the rows in one by one. Whenever the on clause meets, then we know it's a match. And of course, here we need to have a where clause. The where clause is applied in instructor first. So it's indeed from course to join instructor where clause with where clause with the on, right? Again, this is the table by table row with some join condition. And the third one, select, may look a little bit more complex, but if you identify that, it's still select star from course. You get each row in the course where exists, and now you have the join condition or the correlation condition inside the parenthesis. So you are pushing the current row's instructor name inside to get the filter. That will be a where clause, right? So here, instead of selecting from instructor where the instructor affiliation is to Jedi, now you have one more condition where the instructor name equals to something, which comes from outside. And if you think about this, this is nothing different from a join. The only difference here that can happen is the select. In the join part, you can not only select the course columns, but also the instructor columns. So for this reason, join is more versatile. But on the other hand, which one will perform better? It's hard to tell. It's hard to tell. You have to run certain queries on your own and look at the query plans of DBMS. And that's the only way you can identify. There's no easy way to tell which one definitely beats another. Okay, so this is for filtering based on another table. How about updating from another table? So I'm creating 2 tables here, T1, T2. T1 have a currency. The idea is For T1, T1 is some amount. So in T1, you have the currency value and have some amount stored. Then the US dollar amount, equivalent US dollar amount is now. But in table 2, I have the rate, conversion rate between the currency and the US dollar. So for T1 table, I have two records. One is a for T1 table, I have one record, which is a European euro, 1 euro. And I want to know what's the USD dollar equivalent. And T2, I have the conversion of euro to US dollar, which is 1.2. So when I try to update T1 and set the US dollar amount equals to the the local currency amount times the conversion rate, right? There's nothing wrong about it. Now we have the from T2. So when you see from T2, you actually need to realize that it's a from T1 and T2, where T1 currency equals T2 currency. That's where you join. You're joining these two. And when you run this update, you are going to go through every row in T1 first. You will get the euro 1 now, and then you go through T2. And here, T2 is euro 1.2. That's when you have like this, T1, and followed by euro 1.2, right? So this is when you have the two rows, and they are matching. The euro versus euro are matching. So this US dollar amount will be 1 times 1.2. Right, let's run this. All done. Now let's select from T1. Now the US dollar amount equivalent is the 1.2, comparing to what we inserted was now, right? So we updated this successfully. Now, what if I have another row of 1.6? The rate is 1.6. It's also euro, but it's 1.6 in T2. So we mentioned that the T1 must be functionally dependent on T2. But now we have two rows in T2 with the currency is a euro. While in T1, there's only one row. So the one row in euro in T2 will have two different matchings, two different rows matching. When you do update, what will happen? So what we are going to get is 1.2. Now, but this does not give us any assurance. The reason is this is random. You cannot, this is unpredictable, it just happens. In this case, it's 1.2. There's no reason that Postgres will come up with 1.6 next time. So this is something that you need to pay attention, and you can see that there's no error. Nobody tells you that there's a multiple rows happening, and Postgres just picked the random one. So you have to pay attention to this yourself and make sure when you do a multi-table updating, the from tables are in one-to-many relationship with T1, or put it the other way, T1 is functionally dependent on T2 is functionally dependent on T1. Okay. So now let's drop the tables.